Now let's take a look at the MCQ for vectors. Vectors P and Q are drawn to scale, which gives the vector P plus Q. When you do an addition of vectors, it's always tip to tail addition. So based on this, P plus Q would give you a resultant vector like this. So based on the size of the vectors, the answer should be A. Next, vectors P and Q are drawn to scale, which represents the vector P minus Q. So this is minus Q. So vector subtraction is also tip to tail, but the reverse vector over here. So it's tip to tail or reverse minus Q. Alright, so the final vector over here will be P minus Q. Based on the size of the vector, it should be C. Let's take a look at question 3. What is the vertical component of this displacement vector? Since this side is separate from the angle, so it must be a sine of the 37. So that will be 5 sine 37. The answer will be A. Next, what is the horizontal component of the force shown? The horizontal component is on the ground. Since this is connected to the angle, so it will be a cos 53. So the answer will be 20 cos 53, and the answer should be 12. Next, question 5. A pendulum bob is held stationary by a horizontal force H. The three forces are acting on the bob shown in the diagram. Now, what we need to do is to resolve the force T into the vertical component and the horizontal components. Alright, so let's first put in the angle. So the angle here is 30 degrees, which means by alternate angles, this is also 30 degrees. Now, since this is connected, this side must be a cos 30 because it's connected to the angle, so it's T cos 30. And since this side is separated from the angle, so this must be T sine 30. Now, so let's take a look and redraw the diagram according to T cos 30, T sine 30. Then after that, we have two forces, H, and we have a force W. So it makes sense that T cos 30 will be equals to W, while T sine 30 will be equals to H. So H is equals to T sine 30, and W is equals to T cos 30. Oops. Okay, so the answer will be C. Let's take a look at question 6. A car travels west and a train travels south. What is the direction of velocity of the car relative to the train? So the car is traveling westward at 30 and the train is traveling south at 40. And the direction of the car relative to the train means that the train is the observer. So over here, the train is the observer. Now the observer is meant to be stationary. Okay, so what we'll do is that we'll put the observer's velocity onto the car. So what we do is that we flip around the observer's velocity onto the car. Now this observer's velocity can be removed. So the car's relative velocity, car relative to the train, will be in this direction. So the car relative to the train, we have to calculate the angle carefully. So over here, using a tangent, we find out that the angle from the north is 37 degrees. So the bearing over here will be 360 minus 37 degrees, which will give us 323 degrees. Next, two forces, each of 10 newtons, act as a point P as shown. The angle between the directions of the forces is 120. Which is the magnitude of the resultant force? The easiest way to do this is to use a cosine rule, right? Okay, so the cosine rule, drawing the geometry, first of all, we need to draw a parallelogram. Okay, we draw a parallelogram over here, and the resultant force will be the diagonal of the parallelogram. So we can see that both of these are 10, so this is 60, and this will be 60 degrees. By symmetry, this is also 60, this is also 60, this is also 60, and this is also 60. So the resultant force will be 10 newtons due to equilateral triangles. Next, question 8. In still air, a bird can fly 10 meters per second. The wind is blowing from the east. So here is the wind. The wind is blowing this direction from the east at 8 meters per second. Now the bird wants to travel due north. Okay. So which way must the bird fly in order to head northwards? So the bird must head towards the east a little bit at 10 meters per second in order to be blown back by the wind 8 meters per second. So the bird will fly to the right, and then after that the wind will blow it back to the left, meaning that the final velocity will be to the north. So the angle that she has to fly, the bird has to fly, will be arctan 8 over 10. And this angle will be 39 degrees east of north. Right, so I suppose the best closest number that we can get is 37 degrees east of north. So sorry, let me repeat again. The trigonometry we'll have to use is an arcsine instead of an arctan. Okay, so in order to find the angle theta over here, we need to do an arcsine of 8 over 10. And the arcsine of 8 over 10 gives us a value of 53 degrees for the angle over here. So the answer is C. The value of the angle is 53 degrees east of north. Now next, an aeroplane can fly at velocity x when it's moving through still air. When flying in wind, the aeroplane velocity relative to ground is y. So let's take a look at some way that the aeroplane can fly. So the airplane is x, the wind is w. So the result of the airplane being blown by the wind is y. So actually, the airplane's speed velocity plus the wind's velocity will give you the resultant velocity. So let's imagine some scenario. The airplane is flying in this direction, but the wind is blowing in this direction. So the final movement of the airplane will be in this direction. Over here, y. Let's see which one of the following can work. So x is the airplane, w is the wind, y works. So A probably works. Let's check to see if the others work as well. X and W, that should give us a wind direction of y like that. So B is wrong. X and W should give us a direction of wind that is like that. So C is also wrong. X and W, D is also wrong. So the correct answer is A. Let's go to question 10. A particle's velocity is initially 4 meters per second to the east. Subsequently, the particle's velocity is now 4 meters per second to the south. What is the direction and magnitude of the change in velocity? So the way to do this is to draw the velocity on the same body. Okay. So actually any further calculation is not required because the answer clearly is towards the southwest. Next, the initial displacement of a billiard ball is S1 and 20 seconds later the displacement is S2. What is the magnitude of the change of the displacement from S1 to S2? So the ball is over here, S1, and now the ball is over here, S2. So what we need to know is what is the change in the displacement. Now the change of the displacement will be the connection from S1 to S2. In this case, the change of displacement can be calculated using the cosine rule. C squared is equals to A squared plus B squared minus 2ab cosine of the angle between the two. Now let's take a look. This angle is 105. This angle is 75. So this angle must be 30. So it is cos 30. Now, if we punch this into a calculator, the answer is 0.513. So the answer is C. And that's the end of this MCQ.